Before we go to the error analysis, let me give you one more example just to make sure that you guys understood the thing, okay? So the example number 15 from the book, it says approximate the area using trapezoid and Simpson's rule, both method I'll be approximating, and also use calculator to find out that, okay? This is the integral 0 to 2 under the root 1 plus x cubed dx, and n equals to 4. So if you don't use the integration technique, if you use the regular method or the formula that we learned, it is very complicated problem. It is hard to find out the integral here, okay? But if you use the integration technique, or if you use the calculator, also use the use the numerical method, okay? So if you use the numerical method or calculator, let's do first using calculator. I got 3.24131. That's what I got when I use calculator. Okay, now let's find out what do I get if I use the trapezoid rule first, and then I will also do by using the Simpson's rule. Okay, on the trapezoid rule and Simpson rule, A, B, and then A. So n is equals to 4, meaning that we will be making 4 of the sub intervals, right? That's what it is saying. N equals 4. So delta x is b minus a over n. That's what we write, which is 2 minus 0 over 4. That's the width of each of the stripe, right? 2 minus 0 over 4, that is 0.5. So you are basically dividing 0 to 2 into 4 equal parts. That is 0.5, 1, 1.5, 2, like that, right? So how do I find out that? So the formula for x sub I is a plus I times delta x. A is 0 plus I times delta x is 0.5. So that is basically, it is I times 0.5. That's what you get. That is the value of x of I. So what is x1? Just replace I by 1, you get 0.5. x2, replace I by 2, you get 1. x3, replace I by 3, you will get 1.5. And x4 is replace I by 4, that will be 2. Okay. Now what is the formula to find out the the integral? So it will be, so it is just use the formula, right? So a to b f of x dx is equals to what? B minus a over 2n, and you write f of x0 plus f of 2 times f of x1 plus 2 times f of x2, right? And then plus 2 times f of x3 plus f of x4. That's the formula, right? Now you just, so what will be the f of x1 then? Let me use different color for that. So if you use that, f of x1, okay, f of x1 is, you just plug, what is f of x though? So f of x is equals to under the root 1 plus x cubed. Okay, so if you do f of x1, then you get what? So under the root 1 plus 0.5 to the 0.5 is 1/2, to the third is 1/8, right? 1 plus 1/8. That's what you get. Square root 1 plus 1/8. Okay. If you do that, what is f of x2 then? F of x2 will be under the root 1 plus x2 is 1. So 1 cube. So root 2. 1 plus 1, right? Root 2. You see that? Similarly, what is f of x3? F of x3 is, so this is 3/2. 1.5 is 3/2. 1 plus 3 to the cubed is 27 over 8. That's what I get. 27 over 8, right? And then 2 f of x4 is plug in that 2 here, okay? 1 plus 2 cube is root under 1 plus 8, that is 3. That's what you get. Okay guys, so what I'm going to do is I'm going to plot those values, but some of them has times 2, right? So you get b minus a over n is 0.5 over 2. You see that? So what do you get? 1/4. That's what you get, right? Because b minus a over 2 times n. So you multiply the denominator by 2 or divide by 2. So 0.5 by 2. So that will be 1/4, right? F of x0 is so f of x, oh, what is f of x0? F of x0 is 0, so it will be 0, right? You get that? So f of x0 is basically 0 plus let's see, what is f of x0? F of x0 is 1, not 0. Why is that? Because see, x0 is 0, so here x0 is 0, right? If you plug in 0 here, then you will get root under 1, that is 1. So that is 1 plus 2 times that one. How much is that? 1 plus 1/8 is, this is 8/8 plus 1/8 is 9/8, root under 9/8 plus 2 times root under 2 plus 2 times, how much is that? 1/8 plus 27/8 will be 27 plus, sorry, 8/8, because 1 is 8/8, right? 8/8 plus 35 over 8, root under 35 over 8. So everything is under root, okay? Plus x4 is 3, so that is just plus 3. So if you use calculator for this is what you get, 3.283. That's what you get. Okay, so we are using trapezoid rule here. So trapezoid rule actually use the line to approximate the curve, right? On the top we use the line because we join that 2 points, so that is a line. But in the Simpson rule we use the curve, a quadratic function. That's why Simpson rule usually approximate better if the curve is not close to line. But if the curve is close to line, then it will be the similar either method. Okay, 3.283 versus 3.241. Okay, let's use the Simpson rule. So let me use Simpson rule. So what is the formula? A to b f of x dx will be b minus a over 3n, right? And inside the parenthesis or the bracket, whatever you write, f of x0 plus 4 f of x1 plus 2 f of x2. See, whenever it is even subscript, then you write 2, except the first and last. Okay, but there should be even number of sub interval, even number. So 1 2 3 4, there are even number. That's why this is okay. Plus 4 times f of x3 plus f of x4. The first and last will be the as it is, right? So what I'm going to do, b minus a over n is 0.5 divided by 3. So 0.5 divided by 3 is 1 over 6. So plug f of x0. So what is f of x0? It is again 1 plus 4 times root under 9 over 8. That is f of x1, right? Plus 2 times root 2. 2 times root 2, root under 2. Plus 4 times for f of x3. How much is that? 35 over 8. 35 over 8. And then plus 2. So if you use calculator for this, you will get 3.240. You see that? It is 3.24131. It is 3.240 if you use calculator. That's what I got. Okay. So it is almost close to the 2 decimal place, but it is a little off after that. So it is better, right? So Simpson method, usually Simpson method give you the better approximation than the trapezoid rule. Okay, and there are other methods that may be more efficient to do that. Okay, but from comparing the two methods, Simpson method and the trapezoid method, the Simpson method does the better work. Okay, so the next thing I want to do is the error analysis. Let me write down first of all the statement of the theorem, what they do, and then we will take an example. Okay, let's see that. So we want to find out the error, how big or small will be the error if you use Simpson method and the trapezoid rule. Okay, so that is error analysis. Alright, so the next thing I want to talk is the error analysis. Okay, so error analysis will let you know that without doing the problem, without finding the area under the curve using the numerical integration, it can tell you how much can be an error if you use a trapezoid rule or Simpson rule for when you approximate area under a curve. If the question is given without finding the area by two different methods, you can basically approximate how much would be the error if you use Simpson rule and how much would be the error if you use the trapezoid rule. Okay, so there is a theorem, well-known theorem. I'm not going to prove the theorem, but what I'm going to write here is I'm to state the theorem and I'll show you some examples. Okay, so the theorem says that if f has a continuous second derivative on the interval ab, then the error E while approximating the integral a to b fx dx, or area under the function fx between x equals to a and b, using the trapezoid method is error is always less than b minus a to the cubed over 12n squared times maximum of the second derivative of fx, okay, in that interval ab. And also, if f has a continuous fourth order derivative on the interval ab, then the error E while approximating this integral using the Simpson's method is E is less than b minus a to the fifth divided by 180 times n to the 4 times maximum of the fourth derivative of that, okay. So usually this one and that one we can find out using graph, or we will guess, okay. If it is like sine function or cosine function, the maximum will be 1, right? Because sine and cosine function, they always oscillate between -1 and +1, and then the maximum value will be always the +1, right, of the maximum of the absolute value, okay. So let us do this example. What would be the error if we approximate, or what would be the maximum error? Because it said the error is less than, so the error you found using that will be the maximum of that error, okay. So what would be the error if we approximate this integral, okay, with n equals to 4 using trapezoid rule and Simpson's rule, okay. So what I want to do here is, let me write down first what is f of x. F of x is given as what? Cosine of x, right? What will be f prime of x? That will be negative sine x, right? What will be f double prime of x? That will be negative cosine of x. What will be f triple prime of x? Why did I find triple prime? Because I need to do both trapezoid rule. For the trapezoid rule, you will need just the second derivative. For the Simpson rule, you will need a fourth derivative. So I want to do all of them at the same time. So what is the derivative of negative cosine of x? That will be sine of x. And then f of fourth derivative of x will be cosine of x. Okay, now, so number one, I want to using Simpson's. So I don't want to write using, because I'm not using Simpson's, I'm using, so if we use the Simpson's method, what will be the error? Under, let me write under Simpson's method, under trapezoid method. So error is less than b. What is b? So here b is pi, a is 0, n is 4, right? So let me write down that thing. So it will be b minus a is pi minus 0 is pi cubed over 12 times n square is 4 square. You see that? And what is the maximum of f double prime? That's the formula says maximum of f double prime. What is f double prime? That is f double prime, right? What would be the maximum of that absolute value of f double prime? If you do the absolute value of that, that will be positive cosine of x. So cosine of x has maximum value 1. So I will write just 1 there. You see that? Now if you use calculator for this pi cubed over 12 times 16, this is what you will get. Almost, because pi is irrational number, so it will be on non-terminating decimal, right? But if you do that, you will get 0.1615. So that will be the error. So error will be smaller than that. That means that's the maximum error, or error will be smaller than 1.1615. If you are approximate the area under the cosine x using the trapezoid method with n equals to 4, then the error will be less than 0.1615. Let us do number 2. Number 2 will be under Simpson's rule, Simpson's method, okay. Under the Simpson's method, I'm using that one. So it will be E, absolute value of E is less than b minus a is pi, right? Pi to the 5, pi to the 5th over 180 times n to the 4th is what? N is 4 to the 4th times, what is the maximum of fourth derivative? So fourth derivative is cosine of x, okay, and maximum of cosine of x is again 1. You see that? Now if you use calculator for this, then you will basically get 0.0067 That's what you get, 0.0067. Okay, so this is approximately that. So which one has the smaller error then? The obviously the Simpsons method have the smaller error, right? So what it says is, if you want to know just the error, which error is bigger or smaller, without finding the exact area, okay, then you can use this technique to just estimate the error. It doesn't tell you what will be the area. It is not saying you what will be the area. It is just saying which one will have the better error. This one has the better error, right? So it is finding basically the error approximation or error estimate. Okay, guys. So the next example I want to do is, if you want to make error smaller than certain number, then what should you, how many terms you take? Because you see that this error depend on n. These errors basically depend on n. You see that we use n equals to 4 here on both of these. But if n was bigger, if you increase n, then error will be decreased, right? Because that bigger number on the denominator will decrease the overall number. So if you make more sub intervals between a and b, then you get better approximation for the area. As a result, the error will be going down. Error will decline, right? Okay, so this example says that find the number of sub intervals, number of trapezoid or number of stripes. That's what it is saying, such that when approximating this integral by using trapezoid method and the Simpsons method, okay, we will show both, the error e is less than 0.00001. So what should be the number n to make the error less than that? That's what the question is. Okay, so again, as usual, first of all, we will use the same that error analysis formula. Okay, but first of all, what I want to do is, what is f of x? So you get f of x is 1 over 1 plus x, right? And again, what is a? A is 0, b is 1. So we need to find out n equals to what? Question mark. Okay, so what is f prime of x? How do I find out that? So this is, you just move that like 1. So let me write down a little below that. So you can write this as 1 minus x to the negative 1, right? So what is that? Negative 1 to the 1 minus x to the, 1 plus x to the negative 2. So that will be negative 1 over x square. X plus 1 square. Or 1 plus x square. It's the same thing. X plus 1 square. So what is f double prime? F double prime x. So this will be basically, to find out that, you will move like negative x plus 1 to the negative 2, right? That's what you do, right? And then you find the derivative of that. It will be, what do you get? You get basically, so you will get 2 over x plus 1 to the third. That's what you do. Okay, similarly, if you find out f triple prime of x, why do I need triple prime, fourth prime? Because I want to use both the trapezoid and the Simpsons rule. Okay, so if you do that, you will get negative 6 over 1 plus x to the fourth. And if you find out the fourth derivative of x, then you get 24 positive over 1 plus x to the fifth. That's what you do. Okay, guys, now I want to find out n. So first of all, what is the formula for the error analysis? There is, let me use different color there. So number I want to do under trapezoid rule. So what you do is, you write, what is the formula? Formula is this. So this is the formula is basically e is less than b minus a to the third divided by 12n squared times maximum of f double prime, right? F double prime of x in that interval in 0 to 1. So what will be the maximum of f double? What is f double prime? 2 over x plus 1 cube, right? So if you graph this function, the maximum value of that will be 2. Okay, that value will be 2. So that can be written as, so error is less than that, right? but we want that error is less than this one, this value. So what I'm going to write is b is 1 minus there is 1 over 12n square, okay, times the maximum is times 2 is less than that error must be less than or equals to 0.0001. Oh, 401. That's what we got, right? So how do I solve this? This is like just divide by 2, you get 6 there, right? So what do you get? And then you do, so how do I solve this? You get, just write the reciprocal of that. What do you get? 6n square. That's the reciprocal of that is what? Greater or equals to? Because when you do the reciprocal, you see that? So if it is 2 is less than 3, right? But 1/2 is greater than 1/3. So if you do the reciprocal, then the inequality reverse. That means you'll write 1. So it will be 1 over 0.00001. How much is that? That will be 1, and then how many 0? 1, 2, 3, 0. So 10,000. So is that 10,000? How many digits? 1, 2, 3, 4, 5. So 100,000, right? 100,000. That's what you get. So now n square is what? Is greater than, just divide that by 6, both sides by 6. It is 100 and then 0 0, divide by 6. Okay, now take the square root. What do you get? You get almost n is greater or equals to 129.10. that is almost 130. So that many terms are needed if you want to make the error less than 0.00001. Similarly, number 2 is under the Simpson's rule. So what is the formula for E? Is less than b minus a to the 5 over 180 times n to the 4th, right? And then times maximum of f 4th derivative of x. What is the 4th derivative? That is 24 over 1 plus x to the 5, right? So this is the maximum value of this function will be 24. If you graph it, you can see that too, in that interval, in the interval 0 to 1, okay, in 0 to 1. So you can write that from this, what you can write, but this error must be smaller than that number. As usual, what we do is b is 1 minus 0 is 1 over 180 times n to the 4th times 24, because maximum of that is 24. Must be less than what? 0.00001. Okay, so how much is the 180 here? So 24, and 180 divided by 24. Let me use the calculator. So 180 divided by 24 is 7.5. So you write 1 over 7.5 and 4 is less than, or you can write less than or equals to, the error is less than that. So error is less than that, so that can be less than or equal to on that. So 0.00001. If you write the reciprocal, you get 7.5 n to the 4th is greater or equals to 100,000. Now divide by 7.5 and take the 4th root. Then what do you get? You get n is approximately, this would be n is greater or equals to what? I get n is greater or equals to 10.75. 10.75. So which is almost equals to so 11, right? 10.75 is almost equals to 11. So you see that if you use the Simpson rule, you will need just 11. You will have to divide that into 11 subsections, right? But if you use the trapezoid rule to get the same error, that small error, under the trapezoid rule you need 130 of them. But if you use the Simpson rule, you will need just 11 of them. So Simpson rule is cheaper, or it is more efficient to use to approximate the area under the curve. Okay, so this is how we can find out the number of terms needed to approximate the area with a given error size. All right, That's the end of section 8.6. So thank you guys.